Hello, this is Jasmine again. Welcome to the third and final day of our virtual physics event with UMPO. Today's topic is physics of the very big. Yesterday, we learned about the physics of the very small. Today, we are focusing on the physics of the very big. We will start off by learning what stars are and what the life of a star is like. We will then see how we can send stuff into space from Earth and how we can make sure our rockets can land safely wherever they go. So let's start with stars. Do you know how many stars there are in the whole universe? For comparison, this picture of our home galaxy, the Milky Way, shows hundreds of thousands of stars. It's such a big number, it's hard to imagine. There are quite a lot more stars in the whole universe. Scientists don't know for sure, but the number is close to 1 followed by 20 zeros after it. But do you know what a star is? You may have heard that stars are just huge balls of gas. You also might have heard that our sun is actually a star. Since it's the closest star to us, we should learn more about our sun. So as we know now, the sun is a star, and stars are big balls of gas. But what does this mean? It might make it easier to understand if we look at what's inside the sun. The center of the sun is called the core. The core is really heavy and very, very hot. The core is the source of the sun's energy. The next layer in the sun is called the radiative zone. This part of the sun moves the heat and the energy from the hot core into the outer parts of the sun. The outermost layer is called the convection zone. This is the part of the sun which produces the photons that make the sun visible. The outer surface of the convection layer is the surface of the sun that we see. Do you still remember photons from yesterday? Did you know that the sun has an atmosphere? This is called corona, like the virus, but it was named after the Latin word for corona, which means crown. So the atmosphere of the sun is also its crown. And remember those sneaky neutrinos from yesterday? The sun produces most of the neutrinos we observe here on Earth. The simple structure of the sun that we have just described is similar to most of the stars that we know of today. So we know now what's inside a star like the sun. But how did the big balls of gas appear all over the universe? All stars start off their lives as a cloud of hot gas and dust called a stellar nebula. Gravity pulls all of this gas and dust together and forms a young star. Depending on the amount of stuff there was, the young star either becomes an average star like the sun or a massive star. These have very different lives as stars. The star is now a teenager. When the average star grows up, it becomes a red giant. But when the massive star grows up, it becomes a red supergiant. The star is now all grown up. When the red giant runs out of fuel in its core, it explodes into a planetary nebula, so it becomes a small cloud of gas and dust. Similarly, the red supergiant also explodes when it runs out of fuel, but the explosion is a lot bigger and it's called a supernova. Just like in the beginning, these clouds of gas and dust get pulled together by gravity. For the smaller stars, it forms a white dwarf, which can be the same size as the Earth. For the supernova, it depends how much gas and dust there is after the explosion. If there isn't that much, this can form a neutron star, which is a very small but heavy star. If there's a lot of stuff, this creates a black hole. Let's look at what a black hole is more closely. A black hole is a place in space where gravity pulls so strongly that even light cannot escape its pull. This is why black holes are invisible and we need special tools to see them. Last year, using these tools, scientists were able to take this picture of a real black hole in space. It is the first ever real picture of a black hole. So let's get back to looking at stars. Now that we know a bit more about what stars are and how they live, let's ask a question. Why can't we see any stars in the sky during the day? During the day, the Earth faces the Sun, and because the Sun is so bright, it blocks out the light coming from the other stars that are very, very far away. This is not to scale, by the way. The Sun is much bigger than the Earth. At night, the Earth is facing away from the Sun, and we can see all the stars. If there are no clouds, of course. So, when we do see stars in the night sky, they all look like they're white, don't they? But did you know that stars can have many different colors? This picture shows the different colors of stars. The reason we see the stars as white is because our eyes can't see colors very well in the dark. But what causes one star to be blue and another one to be red? It's all because of temperature. The hottest stars are blue and the coolest ones are red. This might seem weird because red is often associated with hot, but have you ever looked at a candle flame's base? You can see that the flame looks blue at the very base and yellow at the top. This is because the flame burns the hottest at the base, and that is why hot stars are blue. We have learned a lot about stars, but let's move on to thinking about how we can send stuff into space. This is a picture of the SpaceX launch of a satellite. As you can see, there is an enormous amount of smoke and fire coming from the bottom of the rocket. Why do you think this is? Well, in order for the rocket to overcome the pull of Earth's gravity, the rocket has to be accelerated to a really high speed. The rocket does this with its engines, which create thrust to push the rocket up into space. So now that we know how we can get rockets up into space, let's look at what scientists have sent into space. This is a picture of the first human-made object to enter space. It was called Bumper Whack, and it was launched in 1950. Laika was one of the first animals to be sent into space, and in 1957 she became the first animal to orbit the Earth. Astronauts on board the International Space Station orbiting the Earth are growing various plants to study how the plants are affected by the strange environment. The Hubble Space Telescope was launched into space in 1990 and is still in operation. It wasn't the first telescope in space, but it has provided scientists with a lot of important data and discoveries. Many people have gone to space, and some of them live on the International Space Station for months. However, sending robots instead of humans is often cheaper and safer. Now let's think about how we can make sure our astronauts, animals, or robots can land safely on the surface of the Moon or Mars. Did you know that the rockets don't actually land on the surface, but they send a lander to guarantee a safe landing? The job of the lander is to make sure whatever is inside it stays in one piece. If there is an atmosphere, like on Mars for example, the lander may use parachutes to slow down and soften the landing. You will learn more about landers with one of our team members, Erin, who will show you how to build and test your own lander. We are now coming to the end of our last day. Let's recap what we learned about the physics of the very big. Stars are huge balls of gas. Stars have a life cycle. They are born, grow up, and grow old, kind of like us. Black holes have such a massive pull of gravity that even light can't escape. Stars come in many different colors. A very hot star is blue, just like the base of a candle flame. Rockets need to beat gravity so that they can be sent into space. The job of a lander is to make sure it is safe for the ones inside to land on the surface of a planet or the Moon. We will hear more about the physics of the very big from our interview with a real astrophysicist. Make sure to watch the interview and don't also forget to watch How to Make Your Own Lander with Erin. This is our last presentation for our event. We hope that you have learned that physics is the study of the very big and of the very small. Do you still remember that atoms make up everything, and that atoms are made up of even smaller particles, which come in different flavors, just like ice cream. We learned a lot about stars and space today. Do you still remember why the sun's atmosphere is called corona, or why we can't see stars during the day? We also hope that you remember some of the physicists we talked about on our first day. Thank you so much for joining us for this virtual event. Don't forget to watch today's Q&A session and the Lander activity video. Please don't hesitate to comment or contact us for any questions relating to our content or our group in general. We hope to see you soon. Thanks, bye.